So today we're going to look at the difference between things that are functions and not functions. And we're going to be comparing three different representations. We're going to be looking at tables, something that are called arrow diagrams or mapping diagrams, and then graphs. So the big idea behind something that is a function is that every input or x value has only one output. Okay, if we look at a table, it's going to look like this. So when you look at your tables, what we'll see is there are no repeating x values. So every x value that goes in has a single y value that it's matched with. Okay, so if you think of this like like a soda machine. If you put $1 into the soda machine, you expect to get one soda out. It would never be that you put $1 into the soda machine and get 2 sodas out, or $1 in and 3 sodas out. That would be a broken machine. So in order to have a function, not a broken function, each input can only ever result in one output. Okay. Now when it's not a function, that's not the case. When you have something that is not a function, you have at least one input that has more than one output. And so if you're looking at a table, what this would lead to is repeating x values. You have x values that repeat and have different y values that are matched with them. When we're looking at mapping diagrams, we can think of these in the same way that we would a table. Okay, the values that are listed for x and the values that are listed for y are matched up with an arrow. So you can see if I turn this into a table, this -3 would match with this 9, we could write the table this way. Same idea where we don't have any repeating x values are going to make it a function. The difference is when you make a mapping diagram like this, you only list each value one time. So this 5 and this y value repeats, but we only list it one time, so all the arrows point to that 1, 5. Okay, so when you're looking at a mapping diagram, the way you're going to tell if it's a function or not is that each x value can only have one arrow coming out of it. That means this x value is matched with that one answer. Now when it's not a function, you'll see that at least one x value has more than one arrow. Okay, so like this here, if I look at this table, this -1 is paired with this 2, and this -1 is also paired with this 6. So we can see when we look at it as a table that we have repeating x values. The way repeating x values look in a mapping diagram is that you have 2 arrows from the same x value. All right, and finally, graphs. Graphs are a little bit trickier to tell. You could turn a graph into a table of ordered pairs if you want to and use our same idea. But sometimes, like when you have a graph that looks like this, it's hard to figure out what values to put into your table. So we have a method that we can use to tell whether or not we have a function, and we call it the vertical line test. If you take a vertical line and you drag it across your graph, as long as it only hits your graph one point at a time, it's going to be a function. That means the x values don't repeat. And I'll show you here on this one. So here I have like -2, 3. I have -1, 2. I'm sorry, -1, 3. 0, 1. And over here I have the value 2, 4. Okay, so it never hits more than one point at a time. However, when it's not a function, and if we do that vertical line test, we'll be able to see that this graph hits 2 points at the same time. Okay, and if we were to look at this as a table, we can see right here where I am, this would be 0, 0, and 0, 2. 2 x values, okay, that x value of 0 has 2 different y values. So when you have a graph and you use your vertical line test, if your line hits 2 points at the same time, or like in this case it goes through a whole section of our graph, it is not a function. Okay, and functions are just relationships. So we're looking at the relationship between two quantities, our x value and our y values. So in this situation, we have a parent using a hose to fill up a small pool for her child. The pool has a capacity of 90 gallons. She turns the water off after 5 minutes. It doesn't say this, but we're going to assume that the pool is filled at 5 minutes, and then leaves the hose in the pool for another 3 minutes before putting the hose away. In this situation, the relationship we're looking at is the gallons of water that are in the pool and the amount of time that's passed since the parent started filling the pool. So we want to look at our independent and dependent variables, because when we have this relationship, it means our variables are related in some way. And what we're looking at is our amount of water compared to the time that has passed. So time is going to be my independent variable, and the amount of water is my dependent variable, because the amount of water that is in the pool depends on how much time has passed. Okay? These two variables can be used to create a graph. Our x values will go across the bottom, so our amount of water, that's our y value. That's going to go up the side. Our dependent variable, amount of water, goes on the left, and across the bottom, that's our independent variable, our time. So what we're going to do is we're going to draw a graph. We're just going to sketch it based on what we see here. So when there is no time that has passed, we know there's no water in the pool. So we're going to start down here at 0 minutes and 0 gallons. And what we're going to see is after 5 minutes, that pool is filled. Okay, that's when she turns the water off. But then remember, she leaves the hose in the pool for another 3 minutes. So time is still passing here. Oops, hang on. That's not a very good line. Time is still passing, but the water isn't increasing or decreasing because she turned the water off. Okay, so that's what our graph would look like here. Now coming back here, back to our function notation, we're going to look at this in terms of a sentence form. When we have independent and dependent variables and we have this function, we say our dependent variable is a function of our independent variable. We can say y is a function of x. That's another way of saying that y depends on x. Okay, and that gives us a little hint that y is our dependent variable. So in this case, what we're saying is y, which is our amount of water, is a function of the time. So the amount of water depends on the time. Okay, and this is just a mathematical way to write it. So y equals, that's like saying y is a function, that's what this f represents, of x. Y is a function of x. Okay, that's the same as saying the function of x is equal to y. This notation is important. Whatever is in our parentheses here with the function of x, this is talking about our x values, our time. Anything that's after this equal sign, or in this case, separated from that function thing, this is talking about our y value. Okay? So the function of x, so the amount of time that has passed, is going to be equal to the gallons we have. So when we look at this, we know that anything inside our parentheses is referring to our x values. So function of 8, that's like saying at 8 minutes. At 8 minutes, we want to know what's our y value. Okay, so our x is our minutes. At 8 minutes, we're looking at our y value, which is our number of gallons. So to find the answer that goes here, all we have to do is go to 8 minutes. We're going to go up our graph until we hit our line, and then we're going to go across to figure out how many gallons that represents. And in this case, it's going to be 90. These two values, this 8 and this 90, are just another way to show the relationship of this point on the graph. Okay, this 8 is our x value, this 90 is our y value. And what it means is after 8 minutes, there are 90 gallons of water in the pool. Okay, let's try another one. So this 5, this is our x value. So after 5 minutes, so come here to 5, we're going to go up, and same thing, also 90. So after 5 minutes, we can also say there were 90 gallons. So we've kind of addressed this situation here when I talked about it up here. What does this mean? So remember, this number in our parentheses is our x value. Our x value, if we want to figure out what that means, we got to look at our label. So we're talking about time, we're talking about minutes. So f of 7 is talking about at 7 minutes. This 90 this is our y value. So we're going to look at this, okay? Our y value is the amount of gallons in the pool. So we would say there are 90 gallons of water in the pool. Okay? If I had a statement that looked like this, okay, f of, let's say 1 equals 60. I'm sorry, not 60, 16. Okay? And I said to you, what does that mean? What I would want you to do is think of it in terms of this kind of format here. At how many minutes there are blank gallons of water. So remember, this is your x value. So this would stand for at 1 minute, there are 16 gallons of water. Okay, and that's just a little bit about function notation. We're going to continue working with this later on. But for now, review this and we'll talk about it more in class.